Good morning. So we are going to start our review for this entire unit today. I'm going to go through all this stuff today. I'm going to start. I'm sorry. Let me start right now with scatter plots and best fit line at the same time. Something we started off in the beginning of this unit. This is for our unit test for thinking with mathematical models for this Friday. So first things first. We got scatter plots, and we need to make a line of best fit so that we can make predictions in the future. So I got two different situations here. This is considered a negative correlation, and this is considered a positive correlation because this goes in a negative direction, whereas this goes in a positive direction. It's pretty clear like that. Now, line of best fit. You got to find a line that, goes through and touches as many points as possible or comes as close to as many points as possible so that you can create an estimated line. For instance, this would be a bad best line because it does not really follow the data. And this would also be a bad best fit because that does not clearly follow the data. So something like right in the middle looks pretty good, and always try to connect some points that are definitive because that makes it easier to identify your actual equation. And I'm looking here at this point. If I were to go something like this, that might be a good line of best fit. And that's going to go through this point over here and also this point here. I got a couple points I could use. So my line of best fit goes through at least a minimum of 2 points to make my equation. So if I wanted to, I could use this point here, which is -2, +1, 2, 3, 4. So I could use -2, +4. I could also use this y-intercept. That's always the easiest one to use. And that's 0, 2. Now we already know our y-intercept, so all I got to do is find my slope. So remember, change in y over change in x. Okay, remember, m is change in y over change in x. Don't forget that. So you're literally doing 4 minus 2 over -2 minus 0. 4 minus 2 is 2 over -2, which is -1, which makes sense because this is going in a negative direction, so that all makes sense. So our line of best fit is going to be y equals -x plus 2. We do this so that we can make predictions in the future for whatever this data might suggest. Like for instance, what would y be if x is 45? Well, what's y if x is 45? Well, y is -45 plus 2, so our model predicts that it's going to be a -43. This is all for prediction standpoint. Over here, same situation, positive correlation. Again, you got to find a line that goes through as many points as possible and touches. So we have something like this. Now I'm not going to have a definitive y-intercept. So now I got to figure out what makes the most. Do I go like this or do I follow something like this? And I'm thinking like I'm going to go through. I think I'm going to have to do something like this. Okay. That more or less follows my data, and I purposely did this because I'm going to use 2 points to make my predictions. I got this point here, which is -2, 2. I got -2, 2, and I got this point over here, which is 1, 1, 2, 3, 4, 5. All right, now I'm going to make my equation of line of best fit based on those points. So I'm literally doing change in y, so this is 2 minus 5 over -2 minus 1. So 2 minus 5 is -3 over -2 minus 1, which is also -3. Negative over negative is a +1. So right now I know my slope is 1x, which makes sense because it's a positive direction. So this is y equals x plus b. I got to find my y-intercept. I can't assume that that's what it is, but maybe that's what the math will prove. Just 1 second. So I'll use this point right here. I could use this point, but I'll use this point. Replace x and y with these 2 points. 2 replaced with y. X is -2 plus b, and I'm going to add 2 to both sides. So 4 equals b. It looks like that is the correct one. So y equals x plus 4. That is our equation to model this scatter plot.